Okay, here we will try to solve a system of differential equations using matrices. So let's say our system of differential equation of degree 1 will be given by y hat equals ay. And our matrix A is given by 0, 1, 0, 1, 1, 1, 0, 1, 0. So we want to find the general solution of that system. So how do we proceed? So first, what we'll do is find the eigenvalues and the eigenvectors of A. Okay? So we will solve the determinant of A minus lambda I equals 0. Okay? And so if you solve that, you get that negative lambda times lambda plus 1 times lambda minus 2 should be equal to 0, and so you get that lambda 1 is negative 1, lambda 2 is 0, and lambda 3 is true. Okay? And so if you search for the eigenvectors, you will get that, let's call them E1, first eigenvectors for lambda equals negative 1. It will be equal to 1 minus 1, 1. So it's basically the span of the vector, but we can take whatever vector we want. Okay. Our second eigenvector for lambda equals 0 will be given by 1, 0, negative 1. And the third eigenvector for lambda equals 2 will be given by 1, 2, 1. Okay. And so we can write our diagonal matrix. So its entries will be so basically our goal will be first to write our matrix A into the form T, T, T inverse, and then we will be able to find the general solution of that system of differential equation. Okay? Yeah. So our matrix D, diagonal matrix D, will be its entries, its non-zero entries will be the eigenvalues. So negative 1, 0, 2, 0, 0, 0, 0, 0, 0. Okay. And T will be T will be just to be the eigenvectors associated to these eigenvalues. So it will be 1, negative 1, 1, 1, 0, 1, negative 1, sorry, 1, 2, 1. Okay? Yeah. And so basically, our general solution let's call it our general solution y of t will be equal to basically it will be equal to c1, some constant or scalar, times e to the power of the first eigenvalue, so it will be -1, times our variable t, times the first eigenvector, so 1, -1, 1. Okay? Plus c2 times e to the power of the second eigenvalue, which is 0, so it will be e to the 0 power times t, so that will just become 1, times our second eigenvector, so 1, 0, -1, plus c3 times e to the power times e to the power of the third eigenvalue, so 2 times t, times the third eigenvector, which is 1, 2, 1. Okay, and so this will be the general solution of a system of differential equation. So what you do first basically is you find your matrix. Here it's already given. Then you find the eigenvalues and the eigenvectors associated to these eigenvalues of this matrix. Then you write A in the form T times D times T inverse, so it will be the diagonalization of that matrix. And then you have this formula where the general solution with a given variable, so here we choose t as a variable, you can choose whatever variable, we could choose x of course. It will be equal to some constants, can call it c1, times e to the power of the first eigenvalue times the variable you choose, times the first eigenvectors, plus, and so on, you go until cn times e to the power of the nth eigenvalue times your variable times your nth eigenvector. And if you have if you have some initial condition, let's say you know that y of 0 is equal to 1, 2, 0. Sorry. You can find C1, C2, and C3. Okay. What you do basically is you put that in matrix form. You take your eigenvectors, so 1, -1, 1, 1, 0, -1, and 1, 2, 1. That should be equals. So if you multiply it by C1, C2, and C3, it should be equal to this initial condition, so 1, 2, 0. Yeah. And so yeah, you can put that in matrix form. You can solve. You can use Gaussian elimination. And so if you row reduce, you will get that C3 basically is equal to 5/6. C2 1 will be equal to 1/2, and C3 will be equal to C1 will be equal to -1/3. Okay, and so you can rewrite your general solution now with the coefficients C1, C2, and C3. So you get that y of t is equal to -1/3 times plus 1/2 times e to the 0 t, so that will become 1. 1 0 1 plus 5 over 6 times e to the 2t times 1 2 1. Okay, so that will be your solution. Okay, so yeah, you can use matrices to solve system of differential equation. So you can first find the eigenvalues and eigenvectors. You write your matrix A in the form T, D, T inverse. So D is a diagonal matrix with and its entries, non-zero entries are the eigenvalues, and T contains the eigenvectors. And then you write it in this form as we said before. So some coefficients times e to the power of the first eigenvalue times your variable, so t or x or whatever, times the first eigenvector, and so on until Cn. So yeah, thanks for watching.